Okay. Well, welcome to the August edition of Space Data Hackers. We are back with our monthly meetup all about space and data, and we are thrilled to have Marshall Culpepper of Loft Orbital as our speaker tonight, talking about a hacker's journey to space. Um, we just to give you a little bit of an overview, we're going to start with a little bit on the Space Apps Challenge, talk with Marshall, and then afterwards, if there's time remaining, we'll do breakout rooms so people can hang out, get to know each other better. All right, so I want to make sure that everybody remembers to join us. We've got a lot of great things going on. Join our meetup. Come to the NASA Hackathon. That's happening October 6th through the 8th. We are doing it here in Seattle, and it is also happening around the world. So I'll just give the lightning talk. I know some of you guys have been to Space Apps. Some of you have been involved in organizing Space Apps. But just to give a little bit of a background for anyone who might be watching this video later. Space Apps is a NASA-led initiative. It brings together hackers, coders, scientists, storytellers, pretty much anyone from every walk of life who wants to come together and work on NASA challenges that will leverage space data to improve life on Earth and our future in space. Here in Seattle, we're going to be kicking it off on Friday, October 6th. On Saturday, the 7th, we will be joined by retired NASA astronaut Wendy Lawrence, who will give a talk. This is very exciting. We're going to be back in person for the first time since the pandemic, and we will have an astronaut at Space Apps, which is always fantastic. NASA released the challenges. They've got over 30 of them. It's an amazing collection of things to think about, to form a team around and hack away over the course of the weekend. And when we say hack, it's truly creative. The challenges embrace all kinds of skill levels, all kinds of disciplines. There's something for everyone to contribute. It's not just coding. Videos and art projects are also ways that you can participate in Space Apps, and things that combine all of the above, so much the better. We are going to be getting ready in Seattle with AWS. They're going to be doing a boot camp at their training center in person here. And that's going to be an intro to how do you get started with space data on AWS. They've got a lot of fantastic tools that make it easy. So we'll have more information about that coming out, but you won't want to miss that. And just a reminder, because I know not everybody here is in the Seattle area, Space Apps is around the world. So go to spaceappschallenge.org and click on Explore the Hackathon, local events, and you can find where you can find your tribe of space data hackers close to where you live. All right. So without further ado, I'm so pleased to be able to turn over the conversation to Marshall Culpepper, currently of Loft Orbital, but also a co-founder of KubOS, the open source operating system for space systems, and a passionate entrepreneur and engineer. And having talked with him a little bit ahead of this event, just was really inspired by the big thinking that he brings to space and data, and how systems are evolving to from Earth to embrace the rest of the solar system. So I will hand it off to Marshall, who will take us through his hacker's journey to space.
Thank you all so much for having me tonight. This is a big moment for me because it's been a little while since I've been able to speak publicly. So I will just go ahead and apologize ahead of time. I may be a little rusty, but here we go. All right, I'm going to share my screen. Here we go. Yeah, and I'm going to get rid of that video window right away. There we go. All right, guys. Well, I've been in the space industry for about 10 years now. And I wasn't always a space person. In fact, I don't think I even really knew what space was or why it mattered until I was in my 30s, which is kind of interesting to admit, but it's true. I really cared about technology, but I just didn't know what was up there. And once I found out what was, I sort of made a beeline to try and find a way to use the skills I had gained in the software world to try and make an impact in the space industry. So I kind of want to walk you guys through my journey, and not just from the perspective of like, oh, look at me and like what I've done, but like more just like to give you guys some perspective on, if you are interested in working in the space industry and you don't have a traditional background, how it's actually very easy to do and possible to do for people that are willing to put in the work. Hopefully to inspire you. That's really my goal. Like I said, my name's Marshall. I'm just a nerd. I really like science and writing code, and I get very passionate about scientific topics, especially space oriented, and I get very passionate about writing code. And those have led me to do some interesting things in my career that I've some early things that I've been a part of. I was an early contributor to the Red Hat and JBoss projects, and to Accelerator and Mozilla Firefox. And those were all before I started in the space industry. And it was around 2012, I would say, that I started to kind of look up at the sky and see what else was around other than what was just on Earth. There's a quote that Carl Sagan has that I think kind of captures the essence of my entire career and my entire journey as an engineer and as a person. And the concept is basically that even though you might like discover things that other people have discovered, if you're going from like a kind of like a first principles like discovery process, when you find that thing out for the first time, it is such a amazingly fulfilling experience. And so, for example, the first time I figured out how to do like a bubble sort, like it's like maybe the most like easy thing you can find online. But when I figured out the algorithm on my own when I was like a teenager, I thought it was like the most brilliant thing ever. Of course, I didn't realize it was not that novel, but finding it, I realized I had learned something on my own. One thing that I really enjoy is doing mathematical proofs, because mathematical proofs are another way where I can, from first principles, arrive at a conclusion or a fact that may have already been found, but because I did it with my own hands, like I know I have the evidence in front of me. And there's just an impact of like being not disconnected at all from reality in that way that I really value from life. And so Sagan really just sort of captured that really well with this quote. So when you make the finding yourself, even if you're the last person on earth to see the light, you will never forget it. And I just think it's very inspiring, just like everything Carl Sagan said. Okay, so I want to talk about specifically, I have a long background in open source and like the sort of the open source world, but it wasn't until 2012 that I started looking up at the skies. And I wasn't really yet obsessed with how I would make it to space. I was just trying to figure out if this was a hobby I actually enjoyed or not. So the first thing I did was I bought a pair of really cheap binoculars, and I started looking at the sky. And of course, the first thing I saw was like Jupiter and like its moons. And there were these like amazing, sort of like line of moons coming from Jupiter. I was like, this is really cool. I can't see more than lines of dots of light, but it's really neat. So I figured I'll get a telescope, see if I can see it better. And so for my 30th birthday, my wife bought me this 8-inch Dobsonian telescope. And that was my son to scale. I didn't have a banana at the time, but it's pretty close. So I decided to use the telescope to look at that same Jupiter. And I realized not only could I see the moon, but I could see the big red spot. I could see the white bands and the orange bands. I could see Saturn with its rings. I could see distant nebulas. And it only took me a couple of viewings of my telescope to become instantly obsessed with the concept of seeing everything there was to see that space had to offer. And so I don't know how many of you know about amateur astronomy, but it's it's a fun hobby. And one of the sort of like crowning achievements you can have as an amateur astronomer, sort of like you can think of it like a rite of passage, or maybe if you want, just sort of like your badge of honor, is what's called the Messier catalog. And so this is a catalog of 110 different distant objects in mostly in our galaxy and in our solar, and a few of them, I think a handful of them are actually other galaxies themselves. And the Messier catalog, the idea is that you want to observe every single one of these. And, the faster the better, but, you're not really going for speed, although some people do. What really matters is just trying to observe them with your own eyes over however long it takes you. Now, about half of this catalog is not visible during certain parts of the year. So only some of it's, visible during like summer and fall, and the other parts visible during like spring and winter. And so what that means is like you really do have to take your time or just burn the midnight oil as much as you can. But it does actually take like quite a while for most people to do the Messier catalog their first time. Usually it's like on order of 6 months or more. And that's exactly how long it took me. I was like very passionate and ravenous and going through it, but there's only so many hours you have darkness in the day, and I live near a big city like most people, so like the darkness near me was not great. I had to start really leaving my city just to see dark enough to be able to see some of these objects, and so that really hindered my speed as well. But I eventually did it. I eventually cataloged the entire Messier thing in my own like journal and notes. And I have no like actual badge of honor other than I just telling you I did it, which maybe I'm lying to you, maybe I'm not, but I can tell you I did put in the hours, and it was so much fun. It was incredible. I saw so many amazing galaxies and clusters and nebula and just incredible things. And if anything, not only did this like fuel my passion for space and what's out there, it just it made me even more curious and trying to figure out how could I do something in space. There's a moment I like to talk about, which was the first time I ever saw Saturn's rings with my own eyes in a telescope. And it was like there, like I was looking at it. And I know that's like an obvious thing to say, but like just dwelling on that in that moment, it was like, it really is just right there, you know? Like I'm just looking at it. Like this is not some abstract 3D rendering that someone's showing me in a website. This is like I'm physically looking at it. And just having that visceral connection with something so large and fantastic really blew my mind. And just like seeing everything in this Messier catalog. And so at this point I'm like 30, 31, and I'm very late in life compared to most people, I would say, catching the space bug, right? Okay, so what else did I do? Okay, so I had already like cataloged all of Messier, and there was a lot more I could have done. But I started becoming interested in astrophotography, mainly because what I wanted to do was I wanted to understand how some of my skills that I had acquired around software and controlling computers and things like that could actually be applicable to the space industry. Keep in mind, I had no idea about satellites or spacecraft or anything like that. I didn't really know how I would go into that world later on. I thought at this point, maybe I could like create a Raspberry Pi that would like control a camera, or like make some software that would like automatically stack some images and do some processing for me. Something along those lines is kind of where I was headed, right? Like I just didn't really know what to do with my skills yet. And so the first thing I did was like, well, okay, first I need to actually get an image to see like what it is that I'm imaging, and to see like if it's even easy to automate or possible to automate. Okay, so I set up what's called a Barlow lens, a very off-the-shelf cheap webcam, which is essentially the same as like a webcam you can put on your desktop computer, but is just like slightly tweaked for like astronomy use. And then some software for like processing the stacks of the imagery called Registax. and then a tracker so that it could, have like relatively stable images. Now, keep in mind, I was on a pretty low budget here. I was not like spending tons of money on these things. You really can, astronomy and especially astrophotography are some of the um, uh, they are like as expensive as you want them to be in terms of hobbies. So I really was just trying to keep things simple. I think I spent maybe all of $300 or $400 at most on this equipment. So okay, so on the right, what you see, if you haven't already guessed, are photos I actually took with this setup. And so the bottom one on the left, Saturn, I could not actually get it to resolve better than that with the with the optics and the light and the telescope that I had. Now, I found out later that my tracker was really, really crude. And so I was losing a lot of stability and therefore a lot of image quality on that Saturn image. If I had to go back and do it again, I probably, with like a better tracker, I could probably create a much better image at this point. But that's okay. It was like my very first one. I was just getting the hang of it. That's okay. As you can see, I improved a lot with Jupiter. So with Jupiter, this is actually really, really close to what I actually saw with my own eyes the first time I looked at Jupiter through the telescope. In fact, I would say it's slightly better, because what I would see typically with on Jupiter with my own eyes is a version of this that the lines across the planet were not quite as distinct. They were a little bit more fuzzy, and you could see the red spot for sure, but again, it was a little bit more fuzzy. So this is actually a lot more definition than what I had seen with my own eyes, and I was like shocked that I could create an image from this whole system that was better than what I could see with my own eyes. And you think about it, you've got hundreds of frames that you're stacking into one image. It kind of makes sense. But once you finally see it and you do the processing yourself, you're like, oh, this actually works. This is really, really cool. And so I was really fascinated by this. And I was like, man, I really wonder, like, how, like, are there ways that I could apply some of these imaging techniques and some of this stuff, potentially like even like combined with some of my networking knowledge in software, to do like my own little like private space program. And so yeah, before I introduce this mission, I want to tell you about a video that I watched in about late 2012, early 2013, that really changed a lot of things for me. I had just had kids. So as you saw, my son was, I think, maybe 6 months older, a year, in that photo with my telescope. And I was like many things in my life, I was newly obsessed with something, and one of those things was my kids. And I wanted them to have an awesome experience, um, building and creating space things and like getting exposed to science and being passionate about the way I am. And there was this video on YouTube where this guy, he had sent Thomas the Train, his kid's like favorite cartoon character, up to near space in a high altitude balloon. And the whole thing was like his kid like going through the process of like preparing Thomas to leave on the mission and going up to high altitude, seeing the backdrop of space and the incredible beauty of that, and then dropping all the way back to Earth. And the entire time, and then the sun, of course, recovers Thomas the Train from the payload as it like lands. And it's like this very, there's a lot of engineering and interesting nerdy things about that video. But what really touched my heart was like how the son and his father had like bonded over this love of Thomas the Train, and he had applied like his love of space to that entire story. And I just was super inspired by this. And so sometimes when you see an idea that's really good, you can't really beat it. You just have to copy it. And that's exactly what I did. So, and this idea was one of those ideas. So I took my daughter, at that time, it was my daughter's favorite cartoon character, which was Curious George. And I'm like, I'm just going to basically redo this YouTube video, but for my kids, because I don't know that I can make this idea any better than it already is. And so, and plus, I love the idea of a challenge of sending something up to, order of magnitude 100,000 feet, and getting it back and like seeing the video and the imagery and all the software involved. And I'm like, this must be kind of what it's like if you send your own spacecraft up. But I know it's like an analog. I know it's not the same, but it's got to be somewhat similar, right? I wanted to see if I could like figure that out. So that was my plan. My plan was to send Curious George to near space, and at least get like the backdrop of space, like in the background. It's like kind of like get really close, as close as I could on a relatively cheap budget. So for those that are uninitiated, high altitude balloons, they typically go in the ballpark, like I said, of about 100,000 feet in altitude. You can get higher, you can get lower, but that's generally the rough ballpark. And I think the world record holder is something like 130 or 40,000 feet. And then like you can get as low as like without, if you're not like being too engineering minded about the helium in the balloon, you can probably pop it like 70 or 80,000 feet. And so, but at those altitudes between 80 and 140,000 feet, you do get the blackness of space, the curvature of the earth. It's pretty remarkable. I'm sure you guys, a lot of you, if you're space enthusiasts already, have probably seen some of these videos on YouTube. They're not exactly hard to come by these days, but back then they were pretty new. So that was my first mission. I wanted to send Curious George to space, near space, on a payload that I designed. Okay, so what does that look like? So what is a payload? What does it even mean? Okay, so this is definitely the opposite of rocket science. Okay, so it's literally an Arduino. It's an off-the-shelf radio. The Extend 900 radio is like, I don't even know if they sell it anymore, but it was like, I think a $70 radio. An LCOM antenna, again, like maybe $100 for that antenna. An Adafruit GPS. I mean, none of this stuff is hard to find. Like this is all very easily accessible stuff. And I think the only thing that's sort of weird, this is just more of a sign of the times of when I made this, was I used this hacked Canon camera that I had that was like a point and shoot. And some hackers had hacked the firmware, and I was able to like put my own software on there. I just wanted the challenge of like controlling a few different systems at once. And so I put my own software on the Canon firmware. I put obviously my own like real-time embedded code on the Arduino Mega, integrated the radio, integrated the GPS, and crucially, the Canon's like entire job in life was to take photos at a fixed rate and then to store them on the SD card for retrieval later. I didn't have the concept of video yet; just static images is all I was going for. And then the Mega, his entire job in life was to send radio packets down on the Extend 900 radio to my truck, which had that same antenna connected to another Arduino connected to my laptop. And so in high altitude balloons, the game is you track the thing while it's moving, while you're driving. And there's this unfortunate fact that like in air, a balloon can go anywhere at once based on the wind, but you can only go where the roads take you in your car. So you have to sort of like play this game of like find the road that you think gets you to the place that triangulates to the place that's going, and also follow it and don't lose radio signal. So it becomes it's a little bit of a game. It's actually quite, I would say, high altitude balloons are a ton of fun. The hardest part is the tracking, and not because of the radio, but just because of trying to keep the car in place. So it's kind of fun. So that was like the whole thing. And as you can see on the side of the payload body, it was very bold lettering. Like this was kind of like my fallback plan if like I couldn't make it work. Scientific experiment, reward if found, all my information. And you guys know I'll have my cell phone number and old address and email address. So feel free to do it that way you will. So that was a basic architecture of this payload. And the only thing extra that you're seeing here, obviously, just some PVC pipe that held Curious George in place, with literally some like duct tape to hold him down. Duct tape works amazingly well in cold temperatures, by the way. And then the body itself, it looks like a giant cube. It's just it's the same kind of foam you can install in like a roof or in like your attic. It's not like the fluffy kind, but it's like the board kind of like insulation foam. It's literally the entire body was made of that insulation foam. I think I got a sheet of it from Home Depot for like $7. I just cut it up into a cube form, taped it up with some like really like shiny stuff. And then the other part, which I don't show here, and I forgot to put it on the slide, is the the balloon itself and the what do you call it? The parachute. And so those are obviously really crucial. With the balloon, you fill it up with however much helium you need to rise to the altitude you want to go. And then eventually, because the helium expands, it just pops once it gets up to altitude, and then it drops far enough, and then the parachute takes over and just kind of glides it down to the end. That's so the whole idea is send it up, follow it, wait for it to pop, follow it back down, and then when it lands, your goal is to just retrieve it, be pretty close by so you can retrieve it and just move along and go on your way. Unfortunately, Curious George was not retrieved because I lost I lost radio transmission and receive about an hour and a half into the mission. So, and actually that's not fully true. So I did actually get Curious George and everything back. And it was that card on the side of the payload body that that allowed me to recover that entire situation. And while I made some technical errors in these sort of like, I actually initially I wasn't sure what went wrong. I realized later that some of like my fundamentals about radios were like really, really primitive. I did not understand anything about pointing of antennas, about gain, or like about like recovery rates when losing data in like a bit stream. Like all these things, I had not taken any of that into account. So not only were all of those definitely issues, but it turned out that the battery that I had the 5,500 milliamp hour LiPo was, it was good, but apparently it had the voltage had dropped off a lot when it got down to temperature at high altitude.
Yeah.
I think that my paneling and my insulation wasn't as good as I expected. So those are the two main things I had going. But the biggest lesson I learned by far on this mission was like, it always pays to have at least one failsafe. And the failsafe in this case was the stupid card on the side of the body, because that 3 months later, I got a random call from a farm in the middle of nowhere, Texas, telling me they had found Curious George and he had made friends with a nest of rats. And so, in other words, he was there. And I was able to. I went to the farm. I actually paid them, I think it was like $50 or $100 I was so grateful to get it back. I cleaned it all off and it was great. I got everything back, but I learned a lot from that experience, but I didn't actually make it to space on that one. The video or the imagery that I recovered from that got me, this is the penultimate photo from the camera on that mission. So it never quite made it high enough to altitude. So I think I also had issues with like filling the balloon itself. Okay, so I needed a comeback. And this one, I will be a little bit faster about explaining. I wanted to give you guys a sense for what it's like to build a balloon. And so Pepper 2 HAB was my second attempt. And this time I took my son's favorite character. And his was Benny the Space Guy from the 1987 Space Guy from Lego Movie, which I also was very much into. And so we wanted to basically do like a second revision of the first launch with all the lessons learned and make it better. And as you can see, it turned out swimmingly. Like pretty much everything went right on this one. We had a few minor hiccups, but it was very, very smooth. So let's talk a little bit about the payload and just like kind of the things that I learned and what went different. So first of all, I upgraded the hardware right off the bat because as much as I like the Arduino, it really is a cool environment. For doing anything sophisticated, like you just want more than the Arduino Mega. It's just not a lot of processor. So I went with a BeagleBone Black, which was actually like an ARM processor. It could run Linux. Like I could run Python scripts or anything else I wanted to my heart's desire. And that turned out to be a much more robust system, funny enough. Worked really, really well for the radio, worked really, really well for interfacing the GPS and all the new sensors that I had added. And it also worked really well for interacting with my new third subsystem, which was my Nexus Android phone subsystem. We'll talk a little bit about that in a second. I kept the radio and the antenna because they turned out to be really, really good. The protocol I was using was not so good, but the hardware itself was very good. So some lessons I learned from that last one. my I think I just kind of all threw it all in there. I didn't really like put any structural thought into how things were going to work on my first one. So I, as you can see here, I was like starting to shim things in and just like make them very well structurally supported. So like things like the IO for the radio and other things like that were very well structurally supported by the foam inside the container. Another thing I did is I upgraded from the Canon like hacked like camera situation to a full-on Android phone that could run not just like an app to take photos, but it could also communicate back to my payload computer and send data on a shorter cadence. And so my goal was not only to send telemetry data back over the computer, but also to send like a very, very small low res snapshot image over the radio link so that I could also see some imagery while I was tracking it just for fun, you know. I wanted to have some submodule communications going on. Okay, so, and then the final system was the GoPro. So the GoPro was a huge win. So GoPro, I just did straight video. I didn't even do pictures with that. It was recording the entire time, and I had it set up on, yeah, with the battery that it was hooked into, it was rated for like 5 or 6 hours of recording time. And I had a giant SD card on there, and I just recorded the whole thing. I didn't have to do any logic on that whatsoever. It was just going the entire mission. So that was like very simplified system. So, and then the major addition from a sensing perspective was a temperature and humidity sensor, which actually turned out to be really good for understanding how cold it actually gets at high altitude. Which it turns out is really freaking cold, by the way. And so I don't think this is going to work. I tried this. Yeah, that's really unfortunate. Okay, so I wanted to show y'all a real quick clip from Pepper 2, but unfortunately, YouTube is not working for me in my slideshow. I will potentially share the link with y'all after the presentation. I think I'm running a little long on time already anyways. So, but the long story short on Pepper 2 is that we were able to recover everything. We were able to track it the entire time that it was up, and it landed in a lake, and we were there at the lake when it landed. And it landed very close to a fisherman and his son. It didn't hurt anyone, didn't land on anyone, nothing was damaged. But they were the ones that actually picked it up. And when they got it, they saw the reward sign. They called me, and I was looking at them across the lake when they called me. And and they said, "Hey, we found your spaceman." And they took a moment to stand up the little Lego guy because he had bent over when it was falling. And I just thought I have it on video. It's one of my favorite moments of all time. Anyway, but that was a hugely inspiring moment for me because the video and imagery we got from this, as you could see, they were fantastic. And I felt like I had gotten so close, and I still wasn't quite there, but man, I've really made a lot of progress. As you can see, I also really upped my video processing skills. I was integrating all the sensor data into the video and things like that. So that's like a lot of fun. Okay, so let's fast forward a little bit. So around this time, around like 2012, 2013, there was another sort of like big change happening in the space industry. And it was around this concept of what's called a CubeSat. And basically, a couple of engineers at a couple of colleges in the US had standardized a physical form factor for satellites that could be very small, require very little power, but be modular in a way where you could kind of just like mix and match, different subsystems and components to create whatever kind of mission you want. And, so think a PC, but like that goes to space, basically. And that was like a pretty cool concept. And, early days of this idea were very academic by nature, but there were a couple of, on top of the academic missions that had flown at that time, there were a couple of like startups in the Bay Area that were interested in like exploring this concept as a way to create new missions that could generate revenue and could generate new businesses, specifically for collecting data for communications or whatever, right? And so this was like kind of early days for the standard, but it was starting to take hold. And there were a couple of big startups at the time that were really kind of the herald of the new CubeSat wave of commercial space. And one of the new startups at that time, and I'm gonna play this one out a little bit, but you'll just come along the ride with me. Hopefully you'll appreciate it. There was a project at the time on Kickstarter called ArduSat, and it stood for Arduino Satellite. And the idea was to put an Arduino on a satellite and to like basically hook it up with lots of different like off-the-shelf sensors, put it into what's called a 1U CubeSat form factor. So I'm going to go back to this slide. If you can see the small little cube looking thing on the left, or sorry, on the right, well, the left of the two on the right. Yes, that one. If you can see that little cube thing, that is a 1U CubeSat. And so basically you would have like 3 or 4 boards in there. And one of those boards would be Arduinos, and one of them would be sensors. Another would be like a radio, and another one might be like attitude control on like a flight computer. So the idea was to let people basically write their own space experiments by using the Arduino IDE to develop really simple Arduino sketches that would interact with the sensors on board, and to charge them per hour that sensor ran, that program ran on the spacecraft. So just to give you a sense, it would be like, if you pledge $50 to our Kickstarter campaign, we will give you 1 hour of processing time on our satellite. And I found out about this project as I was looking around for who was using Arduinos in space, because of all my embedded projects I had been doing with the HAB. And it turned out there was this one startup called NanoSatisfy that was doing this, and it was their Kickstarter campaign that I got interested in. And so there was an article that was like, they were doing like a piece on this Kickstarter campaign that was successful. They had raised over like $100,000 already. And they were like, hey, if you want to work on Arduinos in space, now's the time, call us because we're hiring. And I said, well, I'm just going to stop everything and do that. so I did. I emailed the CEO that day and said, hey, I don't know much about space, but I've built some HAB platforms and I have lots of open source experience. Do you want to hire me to write software for your satellite? And he's like, well, I don't know. and it wasn't the greatest response, honestly. I think he was interested that I was interested, but he just didn't seem very motivated. I was like, well, okay, that I didn't come off right. I was not the best intro. So what I decided to do was, and I had no idea really what I was doing. I decided to write a 3D visualization of a CubeSat orbiting Earth based on coordinates that come from Into.io. And Into.io, if any of you know, is like a kind of like an open data platform for telemetry and spacecraft, and specifically like their locations. And so what I did, all I did was I found some random satellite. I don't even remember which one it was. I don't think it matters. And I plotted the live data stream of the latitude longitude coordinates onto like a very, very primitive like WebGL like 3D rendering on a website. I said, well, you're going to need to track your satellite. Does it need to look like this? And I sent him a link to my thing that I created. And then he decided he needed to hire me, because I guess he had never seen software like that before or something. Because it turned out him and the other founders of that company didn't know anything about software. And by the way, they were making a software company. They just didn't realize it yet. And so I worked for very, very little money for the 3 or 4 months. And what originally started off as me writing their ground control software turned into they didn't even know what to do about their onboard flight software, and they needed a ton just to be able to execute all these Arduino programs. And so I knew Arduino and I knew AVR and I knew low-level code, because that's like, I just had gotten to that point in my career. So I was like, well, okay, maybe I shouldn't write ground control. Maybe I should just write onboard software. And they're like, okay, cool. So I ended up writing their entire AVR, like flight software stack in C and FreeRTOS. I ended up also, once we were done with that, to building their web-based ground software and the team that ran that one. It's all Django based and GNU Radio based in C. And the topper to that was that they also didn't know how they were going to actually talk to the satellite. So, there's two important parts of every mission. The first part, this is going to sound so obvious, but it has to be said. Every satellite has to receive data, and every satellite has to send data. So that means there has to be something to send it and to receive it as well, not just the satellite itself. So you need a ground station, and we had gotten so far along in the program without realizing we were going to need one. It was pretty funny. And so they ran out of options because they were based in San Francisco, and that area is just not well known for like being friendly to putting high gain antennas on roofs. So they were like, well, Marshall, you live in Texas. Do you want to put our ground station on your house? And I'm like, hell yes, I do. So the first ground station for that mission went on my house, and it was a tracking ground station. I got to learn a lot about the hardware, but I learned a lot more about the software, honestly, about mod and demod, and I learned so much about radios in that company. And within about 6 months from, well, I guess it was 6 months from starting, and then 12 months from until it launched. But I was literally like, and this is, as you can see, I'm much younger in this photo. I was literally doing like integration and assembly for a 1U CubeSat in a lab, and to like it actually deploying from the International Space Station. And that was a pretty crazy time in my life because I had done a lot for that startup, and I was like very much all in, and they weren't paying me too terribly much. But that was like the first time I actually got to see something from end to end. Like I wrote every piece of software, or at least had my hands in every piece of software that touched both the insides of that satellite and on the ground as well. So like, if you ever have people talking about space as a hoax, I get very personally offended by things like that, because like I have personally verified end to end that I've sent data to and from space based on my own work. Like I know that that's possible. I actually physically built that mission. I saw it deploy from the ISS, and so it's hard for me to take those people seriously, obviously. But in any case, yeah, it was a life-changing thing, very much like the telescope before it. It was like I finally had achieved sending code to space in a way that was visceral, and I like, all I could think about wasn't the thing I just did. It was like how much more I could be doing. I don't know if that makes sense, but it was like, wow, I'm like, the journey's just begun. I haven't even started. And so, the outcome of this mission, of the RGSat mission, there was actually two RGSat satellites. I don't know if you can see this in the image on the right here, but there's two satellites. The two lower ones are actually identical copies of each other. And they were basically both hardware and software identical copies. And I don't know if you guys remember this earlier when I said the one thing I learned from that mission was to always have some cheap like fallback. And it turned out that having an exact replica satellite that did the exact same thing with the exact hardware and exact software and everything was a total win for us, because one of those two ended up totally dead on arrival. So, and it was only because we had the second one that we had one that worked. And we're not even sure why. I don't think we'll ever know why the first one failed, but pretty interesting. The first thing, and I can't share these photos, unfortunately, because they're not mine, but the first thing that we received from this satellite after it deployed was an image. I mean, after its telemetry, of course, we received the first image from the spacecraft, and it was very low res because it was a low res camera. And it was such a glorious moment because we got our first image from space, and we were all so excited. We all decided to open it and look at it together. And we did. It was around my computer. We opened it up, we looked at it, and I shit you not, it was one of our integration engineers' face looking into the camera like this, like checking it out right before we sent it to space, basically. In other words, we had taken a photo on Earth, shipped it to space, and downlinked it from space. Best moment ever. And so, we had this image of my colleague's face. And so we're like, okay, why don't we take a new image now? And we did, and we got that. And that one was pretty epic, what you would expect from space. Again, I can't show them because I can't share them, but so the outcome of that mission though was that out of all the people that had pledged money to run a mission, run a satellite, or run a experiment on that mission, only very, very few, I think maybe one or two, ended up actually giving us an experiment, which is really weird to me because like a lot of people paid a lot of money to put that thing in space, and like none of them really decided they wanted to do anything with the spacecraft. I was like, that's weird. Like, why would they give us $100,000 if they didn't plan to do anything with it? And that was kind of like my first inkling of like something is not quite right, but I'm not sure what. And the company also figured that out. And the company was like, well, this is not anything to base a business model off of if people aren't going to actually use it. And I think they were right. And so that company ended up changing their business strategy. Instead of going to space to try and allow people to like have a software platform, like a dynamic sort of like enablement situation, what they were going to do instead was they were going to monitor like airplanes and weather and things like that. They wanted to basically be an Earth observation company. And so they rebranded, they changed from NanoSatisfy to Spire. And Spire became one of the first like startups to do CubeSats in the new space industry. And so they're kind of like, it's like them and Planet were like some of the first ones that really decided how to commercialize some of these early satellites. And so after that experience and around the time that NanoSatisfy rebranded to Spire, I decided that like the idea of a software platform for space and like how people could use it was something I still wasn't done with. I was not done with this idea. And I really wanted to pursue because I knew my background was in software. I knew that my background was in developer tools. I knew I could do something that would open up the playing field for more developers, because that was the thing I really was excited about. I wanted more people to have an experience like mine. You know what I mean? Okay. So before I worked at this startup, I was working at Mozilla on the Firefox OS project. And Firefox OS was a short-lived alternative to Android that allowed you to basically run your entire operating system, your entire phone on like web technology. So I was a contributor to that project, and I left Mozilla to join this startup. And then after I decided I wanted to work on the space platform software thing on my own, I went back to Mozilla to try and figure out what my idea was. Basically, I needed the paycheck, but I also needed their support to figure it out. I had been in contact with some of the people that were my managers and bosses at Mozilla, and I had run this concept by them called Firefox One. And the idea, as stupid as it sounds, it really was stupid, was to put the Firefox operating system on a satellite and to develop an application that was written using web technologies, aka like JavaScript, and for Mozilla to basically get lots of marketing out of this play. Like, the satellite industry was still so new, especially small sats and CubeSats, that not a lot of people were doing like these marketing missions yet. And so the basic concept was we would send a phone, like a literal phone, like an actual phone, to space inside of a CubeSat. We would develop some JavaScript-based apps for it that would do like normal satellite things, like take photos and whatever. And then Mozilla gets a ton of press, and they can, do space things. And one of the concepts was maybe the web could be like a fabric for the space industry. Like maybe we could standardize space communications or space technology somehow. And so at first they loved this idea. So they actually funded it. And they gave me a little bit of money to go do another balloon. They were like, well, let's prototype it with a balloon first. I'm like, this is great. I just basically get to keep redoing the things I really love. So I did, I sent a Firefox OS phone with a few people that were involved in the early KubOS days. Before it was KubOS, we sent this Firefox OS phone up to up to altitude, and we got lots of telemetry back. We were able to write the app in JavaScript and have like a little demo. And we even made a video of it, which I don't think it will work based on this, but hopefully it will. Anyways, and so we got to the point where we were ready to now transition to the actual CubeSat hardware, because I'd done this before. I knew what to do. We just needed to buy like the components of the satellite, and we could like put this mission together. And it was only going to cost them like maybe $150,000. But then something really sad happened, and Mozilla killed Firefox OS. And that entire project lasted about 2 years. So it was just a short window there where this was possible. And so with the project being killed, my concept got killed too. But they told me that they really liked my idea and they wanted me to pursue it. Well, I was already pursuing it, but they wanted me to stay on to figure out a way that I could keep it going outside of Mozilla. And then they would let me do that because Mozilla was a great company. They were like, just do what you need to do. And then when you're ready to leave, that'll be fine, but we'll support you until you get this, because they were kind of feeling bad. They pulled out, I think. So I had some of the concepts down. I knew that I wanted to build a software platform for space. I knew I wanted it to be open source. I knew that like web technologies probably weren't the right approach, because like I had prototyped it already and it just wasn't going to work out. It was not very efficient. It was not very speedy. It was not going to be real time enough for like space constraints. But I wanted something like web technology, something that was easier to use and something that developers could embrace relatively straightforwardly. And I also wanted to like make it so that developers could access this stuff while working on serious missions. I didn't want just like fly by night type stuff. Okay, so it's not going to work. I guarantee you. Oh no, it's going to work. Oh, this one works. Okay, so because Mozilla pulled out, I did a second balloon launch, and I needed some money to figure out what I was going to do with this idea. And so this is the first and only ad I ever did with my balloons. It ended up being all of the Firefox OS mission, like hardware and everything. But this little like local moving company decided they wanted to have a tie-in to space with their moving company. I have no idea why. To me, it made no sense at all, but they were paying me money and I really didn't care. So we did this little like cheesy marketing video. I don't know if you guys can hear the audio or not. I'm not going to make you go through the whole thing, but basically this is like it. Yeah. So as you can see, curvature of Earth, blackness of space. Balloons are pretty freaking awesome. Anyways, I didn't want to play the whole video. I just wanted to give you a sense. I think the marketing message on this commercial, there it is. Wherever you're going, we can get you there. Which, it's not the worst in the world, but really space. Anyways, but it's funny. I was very appreciative. So that was kind of like what I did to survive, to figure out my next move, which was KubOS. Okay, so I knew that I wanted to take all these lessons learned and try to build something out of it. And I was like pretty prime in my career. I'd been in a ton of startups at this point to like do my own startup. So that I figured that was kind of like my next move. Okay, so the core concept with KubOS was I wanted to build an open source Linux distribution that anyone could run on any satellite, and then include with it an SDK for developing apps that would run on that Linux distribution. So think Android, right? It's exactly like Android. It's very similar to Android. In fact, I think even in our early pitch decks, we used to say Android for space. And then all of the system components for that operating system were built in C, C++, Rust. But typically they would be open source and modular in their own way. So some of them you could run, some of them you didn't have to run. Just depends on what you need in your mission, right? And then the way we would make money off this entire endeavor, because open source, is synonymous with free, so it's hard to make money in an open source business, was to sell support and licensing for these open source projects to companies that used them on their satellites, and then to have a SaaS platform called Major Tom, where people would buy into operating their missions once they were already in space. And so the SaaS platform, crucially, was not open source, right? So we had to sell something, right? And so this original concept was what birthed the company KubOS. And a lot can be said about the early days of KubOS, but it was one of the most interesting and exciting times of my career. Like we built so much software in such little time with such a small team. And it was a pretty incredible time. I think we stood up probably the biggest open source community that's ever existed in the space industry by a pretty fair margin. We even beat out like Core Flight Executive and other like NASA based like open source projects. And most of it was like universities and hobbyists and things like that. But there was a fair number of commercial companies that were kicking the tires on what we were doing. And so we started off in 2015, 2016 with a little bit of seed money. I built the first version of the operating system and then started hiring people right away. And very shortly after, we had like enough developers to work on not just our OS but also our new Major Tom product. And me and my co-founder Tyler were deep in the business of like fundraising and like making events and like going finding partners who would distribute our software. We were doing the partnership approach on all this. I was supposed to transition slides a little bit ago. We had several different satellite manufacturers who were distributing our software, so like ISS Space and Pumpkin and eventually Nano Avionics and Ruag and others that were like taking our software, putting it on their hardware, giving it as an option to people who wanted to build their own missions. Think like Windows comes with a PC, but instead it's KubOS comes with a satellite. It's kind of a concept. And that was like a really crazy time. Like it took us about 2 years after starting the project and the company to get our first mission to go to space. We had 6 satellites go to space using KubOS. Major Tom is still an active product, and I believe has had well over a dozen different missions that have gone to space at this point. And the whole concept was being the first real software company for the space industry that focused on infrastructure. And ultimately, KubOS itself, as fun and great of a project as it wasn't something that like could make us money in the long term. It ended up not getting big enough and commercially traction enough to justify the cost of like putting resources into it. So we ended up eventually having to sunset the project, and it's still up on GitHub. You can still access it, but there's not been a lot of commits in the last year or two, to put it lightly. And Major Tom is still an active product, and so for about 6 or 7 years, I worked on as CEO. I worked on everything from like fundraising to actually writing software to making business deals and legal and the whole 9 yards. And it was an incredible experience. And eventually KubOS got acquired by a company called Explore. It's actually based in Seattle. With over 20 missions using our software, there's like probably lots of good reasons why that happened. But I would be remiss if I didn't tell you that at this time in my career, and especially at this time in KubOS's history, I had really burned out pretty hard. And I had taken some really, really hard personal mental health lessons. And it took me a while to come back to reality and to be part of the discussion again, if that makes sense. And my co-founder Tyler actually was able to sell KubOS to Explore during this transition period, and I'm so grateful to him for that. But I'm also grateful to him for so many other things. Having a company is hard, but it turned out just another chapter in my journey in learning how to send code to space, because that's the thing I really care about. So it was hard to build a business trying to help other people write code for their missions. But it turns out a lot of missions still need software written. And it turns out a lot of missions that need to exist don't know how to write that software. And so if the metaphor for putting code in space is not similar to writing an app on an app store, or is not similar to you know, writing Arduino experiments. Like, software gets written every day in the space industry and goes on satellites and processes data on the ground. So like what are the things that will go to space and make money? And that's the thing I found myself asking once KubOS was acquired. Like I still care about the problem of what does a software platform for the industry actually look like? And I'm really excited to say that I've recently joined Loft Orbital as a principal software architect, who is a company that has, I think, figured out that infrastructure itself, the space infrastructure itself, is something that should be seamless to an end user. So the thing that I've realized is that writing mission software doesn't have to be about writing an app. It can be about processing data. It can be about creating a requirement and having it fulfilled by both a hardware and software combination. It can, and so I think I thought of the world coming into the space industry as like a general software horizontal approach, like from a framework perspective. But I think what I've learned from coming to Loft is that it can actually be much more vertically integrated. So if all the hardware is fully intact and you have exactly what you need to execute on a specific mission, the code you can write can be very efficient and very easy. And in fact, you don't even need to worry about creating your own hardware, putting it in space, because what you really care about is like, here are the 5 sensors that literally every satellite has, and let's just combine them and do interesting things with them. That seems like where the real money is, or the real potential use cases for this software on these missions. And so I won't be able to talk about it in detail today, unfortunately, because there's still some stuff we have to do. But I'm working now on things that are very similar to what I've worked on in the past, that are much more geared towards data processing and will make it very easy for people such as yourselves to process data in situ. And that's all I'll say about that for now. And I also need help. We're hiring very, very strongly right now. I need Rust developers. I need C developers. I need Python developers. I'm building something really cool, and I'm looking for people to join me on the quest. So that's another way that potentially you could join my my little journey to find where the software in the space is supposed to go. And this is just a handful of links. I'll leave this up for the Q&A just so everyone has a chance to jot them down. All of the code I showed today outside of Major Tom is open source. And so you can go check all of that out here at these different links. Yeah, I think that's about it for me. I hope you have enjoyed it as much as I have.
Fantastic, Marshall. Thanks so much.
Yeah.
He's got questions.
I'll let other people go first.
Should I open the chat? Sorry. Oh, yes, I see things in chat. Let's see. Oh, yeah,
So just
welcome.
a quick note about you need help wanted. Our local KubOS group, Cascade users of open source geospatial software, is like a whole collection of people that write the open source libraries. Are you familiar with GDAL, for instance?
I'm not. What is it? GDOL?
GDAL.
No,
It
I can't say I'm.
so yeah, we have a wide collection of different skills in different languages, etc. And they post notes. We get job notices and stuff via the mailing list in the various forums and stuff like that. So contacting them and getting permission to make a posting would probably be very fruitful for you.
Okay. Oh, I'll check that out. Thank you. I appreciate that. GDAL.
I'll also
Okay,
say if you
interesting.
want to stop by Seattle's Space Apps event, probably find a developer or two who could be handy. Maybe
Yeah,
some
man.
Python, probably some C.
Yeah. I think yeah, I think I probably will. I as I said earlier, this is my first public speaking engagement in a little while, and it's been quite. I've been mentally preparing for this day since you asked me. Actually, since Nicole asked me, and but I'm really excited about getting a little bit more involved in the public sphere again. So, yeah, coming to an event sounds good.
Question from Michelle.
Hello, thank you so much. This was very, very exciting and very, very cool just to see your journey and just how you engineered your way throughout this entire journey through trial and error. It's really cool. I'm an engineer too, and I'm about to start a full stack boot camp. And so I'm curious. I have a question. I've been learning lots about satellites. And I'm an entrepreneur, so I'm curious to know what is the best way to reduce latency using software?
Oh man, that's a very, very loaded question.
Well,
Okay,
if I can
so
only have one, I want to ask you that one, a loaded one.
a latency. Okay, so the traditional answer to your question is that in order to be very, very certain about your latency, or specifically to be very, very certain about your timings, because timings in a sense matter more than latencies in a software world, you want to use a real-time system for those kind of concerns. Now, there's a huge caveat and a huge asterisk next to that recommendation, which is that it depends on what your constraints are. So if let's say that you get a radio transmission and you want to like acknowledge and respond to that within, let's say, 100 milliseconds. If it's 100 milliseconds, you don't need real time for that. 100 milliseconds is definitely within the slew of error of like a normal operating system like a Linux. So you don't really need to control too much for a timing of that constraint. But if your constraint for a response is more something like on the 1 millisecond or like sub millisecond, like hundreds of microsecond level, then you might want to start thinking about very guaranteed constraints around timing, because again, with real-time systems, what you get, it's not necessarily speed. Some people think of speed when they think of real-time systems. That's actually not the thing. The thing with real-time systems is guaranteed timing. So in other words, if I do XYZ, every time I do XYZ, it takes the same amount of time. And that's really powerful because then you can predict based on doing XYZ when in the future I need to do it so that by the time it's done, the latency I'm trying to achieve is possible. Does that make sense?
Yeah, that makes sense. But I'm curious, does that also have to do with the hardware, like processing on the, like,
Yes.
would you actually have a processor on the satellite to be able to do that?
Yeah. Oh yeah. Yeah. Like I don't know a satellite that doesn't have a processor at this point. I've not seen one.
But like how strong, I guess I would just say like what kind of processor would get you into the nanosecond range? I guess that was a better
Nanosecond.
question. Yeah.
Yeah. Nanosecond. Yeah. For real-time systems, a nanosecond, you're probably going to want like FPGA level for that, because yeah, you're going to need to be in very much complete control of your timings, and you might even need sub, because so you're talking about transistor timings at that constraint, and so the only thing I know of that can pull that off is an FPGA or an ASIC. So
Okay. Thank you.
you can get tens or hundreds of nanoseconds in real-time software.
Towards that same area of the question, so the latency is is a thought experiment. How long does it take that satellite to go horizon to horizon when you can communicate with it, and then scheduling the messages that are going up and down. And then if you have more than one satellite or more than one ground station, because that all, in other words, the point I'm making is the latency exists at all sorts of levels in timing, etc. So could you speak a little on that as much as you can? Yeah.
Yeah. No, yeah, for sure. I mean, like you said, there are latencies at every step of the process. And so, what we do in the satellite world to account for latency is we plan, right? So in other words, we know that if we need a response by X and it takes Y to get that data, and then Z latency once that command is received by the satellite to send that data, we added X, Y, and Z up together, to schedule that chain of commands, if that makes sense. And so that is normally the way that that's handled. And a lot of that logic today is handled on the ground, I would say. We're kind of entering a new world now, like just now, I would say, where some satellites in the space industry actually have some intelligence on board and can do things like some intelligent routing and things like that. And it's only because of this recent advance that things like being able to do onboard data processing with imagery and hyperspectral data and other kinds of Earth observation are even possible. And we're really at the very, very early stages of that. So I think, I guess, to the question you asked, in a ground system, most of the challenge in a mission is just like making predictions about and controlling for all the variables in your ground station schedule. Because no matter how good of like a prediction algorithm you've got, everything is always going to be slightly different over time. And so you've always got to reincorporate the latest sensor readings into your model. Otherwise, it's basically useless, at least over a certain period of time.
So how do you know it's right? Testing it
Because, well, you
run a
know it's right.
simulation that includes all of the stats and maybe throw some random stuff in there?
And yeah, you'll run lots of simulations for sure, but the way you validate anything in the real world is you like make a prediction and then observe it, right? That's just that, it's science 101. So what we do typically in the satellite world is we'll make predictions up to the point of a ground station pass, and then if the prediction holds true, then the pass works, and if it doesn't, then it doesn't. And so now the prediction must change. Right. And luckily there's been enough of that going on in the last 50 years over like not just like industry, but like government and everything else, that like some of those like methods are pretty well known at this point. And so there's not a ton of mystery left in that, but it's I see that every new organization that pops up that has to solve this problem has to kind of go through like a mini version of that learning process on its own. Going back to the kind of like the main thesis of my entire presentation, which is that like sometimes it's better if you learn things from the ground up because you'll learn it much better that way.
Hey, Marshall,
So
I have a question.
There's some questions in the chat. If maybe I could shout them out to you.
Yeah,
Rebecca. Zach was asking about, does your current project include edge compute capabilities?
Yes, it does.
Real-time data processing or okay.
Yes. Yeah, we I think what I can say is that we've made some public announcements with Microsoft. So if you're interested in what they're doing, or what we're doing, happy to, if you want to drop me an email, happy to tell you more about that.
And then storage on orbit. Kyle is asking, I keep hearing that the on-orbit storage requirements are growing up. What are the biggest challenges and opportunities?
Yeah, that's a super interesting one. I think the biggest opportunity for storage on board right now is a reliable, high capacity flash storage. If somebody can figure that out, there's lots of money to be made. So yeah, that's like a whole, that could easily be a huge business because, okay, here's the issue. You can, if you want, just put like a random SD card or eMMC into your satellites. And in fact, many do actually. The problem with eMMC is that it's very prone to radiation damage. And like, it's hard for eMMC in space to last much longer than like a year or two. And so there are a handful of companies, I think like one or two, that have figured out how to do radiation tolerant SSDs with like, you know, a couple hundred gigabytes of capacity. I mean, guys, like it's 2023. I don't know if y'all heard, but like hard drives are in like terabyte storage space now. I don't know. So if you can figure out how to get terabytes of storage with high reliability, I know my company would be happy to be your customer right now.
And I think there's one more question from the chat, and then Abhi, we'll throw it to you. Are there test cases to simulate the satellite journey under different conditions in KubOS, like being in the sun, battery conditions, etc.?
So yeah, so this is one thing KubOS was never super good at. We never really did simulation very well. We leaned on some of the tools that were created by the folks at NASA, like 42, and things like that could use and extend KubOS, or like could like plug into KubOS, but they weren't part of the overall system. And this is where things like SDK are much more mature and much better, honestly. So I would say if you're looking for those sort of like novel simulation experiences for a mission, I would highly recommend you go check out. Unfortunately, it's not cheap, but SDK is probably like the best in the business. Gosh, there's just not really a ton of, like 42 is good. 42 is pretty good. It's better for like lunar missions, I would say, than solar. But and then if you're a hacker and you like JavaScript, Cesium is another route you might go down. You could do the simulation in JavaScript. Cesium is a great project too, by the way.
Don't necessarily be intimidated by the $150,000 a seat that they want for some of this software, because actually, if you talk to them and if you taken a community college course, or can give them any excuse to give you the educational discount or arrangement or whatever, I have found most of them very, they want to increase the pool of labor that can work their software, because it's a pretty narrow zone.
It is, yeah. They really were the first like software company that tried to do anything in the space industry, I would say. And they figured out pretty early on that like you got to like get them while they're young and get them while they're get them while they're impressionable.
Abhi, thank you for your patience.
Yeah, no, I'm sorry. I couldn't find the button to raise hand like more gently over there.
No worries.
Hey, Marshall, this was very cool. So very cool, like very inspiring and awesome. So I have a question about the Azure Orbital ground station.
Mm-hmm.
So do you have any comments around as in well, the burning question is how mature is it, or what's the adoption out there?
Oh man, you put me on the hot seat with that one. Okay, so what can I say? So with Azure Orbital, I wouldn't say, okay, it's still pretty early for them, but I know that they've got missions under their belt, and I know that they're working with companies that I respect. There's been a few people here, even at this talk, that are, I think, currently working with them. I know that their partnership with KSAT was like the right move. Like KSAT's probably like the industry gold standard for small sat communications right now. So I think they've made some good choices, and I think they're more open to collaboration than other cloud infrastructure companies that begin with the letter A might be. But that's just I'll say about that. So you asked me two questions. Was one, the reputation of AWS ground, and there's a second one that I forgot now.
Yeah, so in adoption, in terms of so as your approach, right, was more like building up from the ground, and yeah, and that, that's just, it has all its advantages, right? But if the industry is moving at a pace where, there might not be that luxury of that much time, right? And of course the brain power, because there's not too many of, Marshall Culpeppers out there. I'm sure you're working on those.
I'm trying.
Yeah.
Doing everything I can. Yeah. But wait. Yeah. So thank you for that. But I will say, like, there's no shame, just because I like to build things from the ground up doesn't mean there's any shame in like using what other people have done to make progress. And I mean, I do it constantly in my job too, right? So it's nothing wrong with that. So with regards to Amazon, or did I say Amazon? AWS, did I say AWS? With regard to Azure, they all start with A's, don't they? With regard to Azure ground, I do know that adoption is early for most companies that are using it. And I know Loft is starting to look at it. And I know that others are too. And I'm not personally aware of a successful mission yet using it. That doesn't mean it doesn't exist. I'm also a little bit behind on the times with regards to news. I think the framework that they've used is like relatively okay. Like, I think like it's easy enough to use. The APIs are relatively straightforward. I think that Microsoft is in it for the long haul when it comes to their ground products. And so I wouldn't question whether they're a good long-term solution. But here's one thing I'll say. I think the big tech companies, specifically Microsoft and Amazon, are still learning in the same way I've been learning about space. In other words, like, it may not be a safe assumption that you using them will be any different than you learning it from the ground up. If that makes sense.
Okay. Yeah, in terms of like getting there, the speed, right? And
not just the speed, but like you might have to handhold them through stuff that you learn because they're not in the space industry really, right? They're
okay. Yeah, okay. So so what you're saying, it's really not off the shelf-ish yet.
Not yet, not as far as I can tell. I think, I mean, don't get me wrong. I think it's probably, in terms of an enablement, I think it's like a huge value add for anyone who wants to start there. But I don't think I wouldn't think of it like an EC2 yet. Like, it's not the thing where you like put in your credit card number and suddenly you have ground stations. Like, it's not that, right? For all kinds of reasons. That's not even their fault, by the way. A lot of that has to do with regulatory. Just to be able to get to that point, you have to like have all these licenses, and like they're still figuring out how to exist under that regime, right? So that's not even a technical problem. That's just a regulatory problem. Anyways.
Okay. All right. Thank you very much, my friend. It's been a pleasure. Thanks.
Yeah, my pleasure.
So, just a point of interest is the U.S. Space Force is got a pretty large initiative around open source projects and not necessarily requiring security clearances and stuff like that. So they've been sponsoring hackathons and competitions and things. So Marshall, are you familiar with any of those?
A little bit, yeah. KubOS was involved in a couple of hackathons centered around security and cyber, with space in mind. Right, like in the late 2010s, like 2018, 2019 timeframe. I think we were used by like one red team to try and like penetrate a specific satellite target. And it was like it was on the ground. It wasn't in space, by the way. That's about as much as I know about it, to be honest. We at KubOS had gone through several potential contracts around cyber with our open source software, and had actually gone through a few different audits of our not just our source, but our dependencies and things like that too, to try and get qualified for certain kinds of missions. But even though we did it, it never ended up mattering too much for us. So I honestly think we were maybe just a little too early.
Just
Yeah,
making
it's-
it through it is an immense achievement.
There's a reason why I have more gray hair now. Like, oh, there's several reasons. That's definitely one of them.
This has been fantastic. I'll pull one last question for Marshall from Patrick in the chat. Do you have a favorite conference or event you go to keep up to date?
Oh my gosh, that's such a good question, and I'm gonna apologize ahead of time because my answer is not going to be nearly as informative as it was 3 or 4 years ago when so like I said, I'm sort of like getting myself back out into the open now too. And the event I know, I think this is still true. The event I know is like the event to be at every year in the space industry is SmallSat. SmallSat is the event to be at. If you want to go to, like, especially I would say this is actually maybe a really good time to give some advice. Like, my co-founder Tyler had no space background either. Neither one of us did when we first started KubOS. And the way he broke into the space industry, which was separate than my story, was he would go to every conference and he would just bother people until they talked to him. And he was really good at it. He was amazingly good at it. He's one of the best people. I don't know, whatever that is. He's one of the best of those guys that I've ever met in my life. But I can tell you, a really good use of time if you're trying to get into the space industry and you don't know really what to do next is to go to SmallSat. SmallSat is where all of the players are, like up and down the supply chain of the space industry, and thousands of people go. It's as nerdy and engineering centric as you want it to be, or it's as business focused as you want it to be. It has every facet of interest there. There's investors there, there's engineers there, there's everything. And it's in the middle of, like, excuse my French, bumfuck nowhere, Utah. And it is just a magical thing because it's at like a college campus. And, like, I don't know, you don't see events like this much anymore. Usually they're very corporate and but this is it's as big as it is, it's still very intimate. It's my my favorite space industry event, and it's very authentic. You can really just meet anyone there, and it's not hard to.
That is awesome. Okay, thank you so much. I'm going to steal the screen back just for a couple of reminders. Okay. Yeah, so Space Data Hackers, we come here every month. Our next meetup will be on the 28th, and we'll be focused on the hackathon and getting ready for that. And the very next day is the AWS Boot Camp in Seattle that I mentioned. And the week following is the NASA hackathon. Please be sure to register and be a part of something incredible that only happens once a year. And be a part of Space Northwest. Come and join us. If you're interested in being connected with our events, we've got opportunities to flex your skills in marketing, social media, sponsorship if your company is interested in sponsoring the hackathon or any of the Space Northwest events. We are very happy to hear from you, as well as folks who want to take part in planning and logistics, space data mentors, and data analysis. Please hit us up at info@spacenorthwest.org. And with that, I will conclude our excellent session tonight. Thank you so much, Marshall, for telling us all about your journey and spending the time to answer questions. We look forward to perhaps seeing you again in the future, and all the best with your endeavors at Loft Orbital. And for everyone else, Have a wonderful night. We'll see you next time.
Thank you. That was great.
Thank you so much, Mike. Thank you,
Thank you,
everyone.
Marshall.
Thank
It
y'all.
was
Thank you.
true pleasure.
Bye.
Bye.
Bye.